Welcome to Comet Computer Private Limited, e-learning program of hardware and networking. We are discussing about storage technologies, magnetic storage devices. In that hard disk part 1 we have completed. We are entering into part 2. Part 1 we have discussed about the hard disk internals like platers, head, actuator, arms, spindles, and different timings like seek time, access time, average seek time, about tracks and sectors. So all these details we have seen. So further we'll see in the part 2. So in this we'll see about partitioning. So when I'm buying a hard disk from the market, so can I store the data directly by just connecting the hard disk into the system as a primary, master, secondary? So can I start storing the data? No. So we cannot store the data directly, not like your USB flash drive or other drives. So it has to be undergoing some process so that it is made ready for accommodating the data. So that process is called partitioning and formatting. There are two stages available. First, what we have to do, we'll be having a raw hard disk, right? Raw material or raw things. So we have to first partition it and create a master board record, and then we'll go for, as a second step, we'll go for formatting, where we'll be creating tracks and sectors and store the data, fat tables. So it will be useful for storing the data. So after that only we'll be able to store the data. You are seeing C drive, D drive in the system, right? The working system. So these drives are created after formatting the drives. So only partitioning will not help. So this is a two-stage process to prepare the hard disk. So if at all in interview they ask like how will you make hard disk as a usable, you have to mention this two-stage process. One is, first is partitioning, second is formatting. So if you are not completing the formatting also, you cannot use the hard disk. Okay. So it is a two complete steps you have to follow for preparing the hard disk to accommodate operating system or any other data. So partitioning is nothing but process of dividing the physical drive space into pieces called partitions. So you have large amount of space available as a drive. You'll have lot of tracks and sectors. We are going to divide that into a smaller sections. So there may be a lot of questions like how many partitions I can have. Can I have single partitions? Yes, you can have single partition as a C drive. So depending on the operating system, like even we can have 2 terabyte hard disk as a single partition, so that should not be a problem. So earlier we had FAT16 kind of file system where we cannot go beyond 2 GB and all. Now we have NTFS file system, and also we can go even exabytes, we can go for partitioning. So latest technology is different. So here we can have single partition or we can have a number of partitions. That is not a problem. So partitioning size also we can decide based on the capacity, but having too many partitions will create a complex for our operations, like you will not know where you kept the data. So normally we'll limit with 3 or 4 partitions. Logically speaking, you can create partitions from C to Z, where you can have 24 partitions. C will be the primary partition where you store the data. But architecture wise, what it says, the fdisk command or the basic thing, you can have maximum 4 partitions. You can have maximum of 4 partitions. So what we will do, we will create 3 primary partitions and 1 extended partition. Under that extended partition we can have many logical partitions. So totally 4 partitions only allowed for the operating system. Logical partitions you can have in n numbers, that is not a problem. So this partition is nothing but we are creating a logical space for splitting the single hard disk into multiple drives, and making separate space for separate partitions. So it starts track 0, cylinder 0. We cylinder, you know, right? In the last slide we have seen, cylinder means track number. Cylinder 0 means track 0 of all the platers. Platers will have 2 sides, 3 platers, 6 sides. So track 0 of 6 sides will be called as a cylinder 0. So cylinder 0, head 0, sector 1, the first sector. So always sector number starts from 1, cylinder number starts from 0. That is a standard we follow. So cylinder 0 sector 1 will have a MBR, master boot record. So there only we are going to store about the booting informations and all, not the bootable files, but the booting information where the partition is available and where the booting files are available. So that will be available in the MBR. So we'll discuss more about partitioning. So before installing the operating system, so we have to go for formatting it. After partition, we have to go for formatting. So there are two different connecting interface we had. One is ID interface, and other is a SCSI. SCSI, we call it as a SCSI. We have to pronounce it as a SCSI. So this will be mostly used for server environment, not for the desktop environment. So we'll focus more on IDE. So last slides we have seen different types of interface and the advancement, like recently we have the ATA model also. So what is the reason for partitioning? So now you know the basic step is create a partition and format it, two-step process. Why I have to go for partitioning? So why can't I stop with only one, or why I have to go for partitioning? So when the systems needs to restore, so if I have only one partition C drive and I wanted to restore the data in other partitions, so I cannot store it, right, because I have only one partition. So if I have at least two partitions, I can take the backup of data in D drive, and even I can format the C drive and restore my system. And next thing is saving massive information on system partition will slow down the computer. So C drive, we have to dedicatedly give it for storing the operating system related files. So if I store multiple data, then the read and write will become slow. That's the reason we don't want to go for higher capacity of partitions. So I can have 100 GB as one partition, or even 1 TB as one partition. So if you measure the seek time, average seek time and all between the systems, the system having 100 GB partition will be more compared to the 1 terabyte partition, because the number of tracks and sectors included in the 1 terabyte is different more, and 100 GB is less. Okay, so at least we can have few more partitions, not like 20 or 30 partitions, and that becomes more complex. So at least have 2 to 3 partitions. So, and we divide, like one partition will be operating system related, one partition will be application related, one partition will be backup. So that is the ideal scenario for designing the partitions based on the capacity of your hard drive. Or you can take backup in the external drives also. You have external hard disk available, just connect it, format it, and use it for your own backup and restoration process. So different type of data should be saved in different partitions, as I just mentioned. So after this partitioning, size of the cluster will be smaller. So cluster is smaller storage unit, and the operating system determines that a cluster can only store the contents of a file. So by dividing the partitions, we are going to have a better management of um, the operating system as well as the data transaction. So DOS and FAT file systems designed for 24 partitions, as just I mentioned, based on the alphabetical order. But we need not go with that because the general management of data and the operating system will become complex. So better go for few partitions only. So as I said, we'll have 4 partitions. There are options to have 4 primary partitions. In that, what I will do, I'll take 3 primary partitions and 1 extended partitions. The reason for having primary partition is at least I'll have 1 primary partition and I can have 1 extended. Under that, I can have logical partitions. Why I have to say primary partition is, this is the partition where the operating system can reside and I can boot from that particular partition. So suppose um, I have stored the operating system in the non-primary partition. The operating system will not boot. So I have to install the operating system in the primary partition and make it as active, so that the system can boot. Even if the partition is not active, the system will not boot. Sometimes you complete the installation process but it is not booting. It means that the hard disk partition is not made active. So master boot record, this is the important one. This has very important informations like executable codes and partition table. So if anything happens to this, and we'll be losing the entire data, and it is very difficult to recover it from the hard disk. So what we'll do is, when you are creating a partition, this MBR is getting created. Normally we use the command called fdisk. It's a command prompt dash mode dash command. So we use this command, and while creating a partition, the MBR is getting created. If at all I have any virus found, so what I will do, I'll just put fdisk/mbr. It will clear the excessive informations, whatever it may be. The excessive information will be removed. Only MBR related informations will be kept, so I can restore my MBR. It's a simple way of restoring it. If at all your hard disk is not booting, first we'll do this thing, so that my MBR is getting clean. If I restart my system, it will work as it is. If there is impact because of a virus, if there is any crash, then we cannot do anything. We have to go for recovery tools, third-party recovery tools. Sometimes that is not possible to recover also, because the entire FAT is getting crashed. So that's the reason. So what happens is, to avoid some of the virus programmers, they focus to crash the MBR information. So to protect that kind of attacks, in BIOS we have got the MBR protection, but we have to enable it in the CMOS setup, so that your MBR data will be secured. And obviously the antivirus software is also coming with MBR protection related to secure your data. Partition types, there are different types of partitions available. One is the non-DOS partition. So it means that it will be a kind of raw device, raw partition, because if at all you wanted to store non-DOS operating system, right? It means that Linux, Solaris, or any other Linux flavors. So you can install the operating system in that non-DOS partition. It will select the unallocated space, and that operating system will boot it from that particular uh, media, and create partition from that particular operating system. So that will be used only for Linux operating system. So we keep separate storage space. If at all I have a plan to have a dual operating system in my hard drive, what I will do, I will create partitions with 50% space, or whatever it is, and I leave the empty space as unpartitioned space, so that when I boot from Linux CD, I can choose the unallocated space, and I can make use of that partitions for storing my Linux data. So that is how we use the non-DOS partition. So primary partition, it is very important. Here only the operating system resides, and important informations are kept. So extended partition is, we create extended partition under which we'll be having logical partitions. So as per the standard, we can have 3 primary partition on 1 extended partition at the maximum, or 4 primary partitions. Otherwise, DOS will not recommend or recognize the rest of the partitions. So under extended partition, I can have multiple logical partitions. For DOS, it will be viewed as single partition, as extended one, not as a multiple logical partition. So fdisk is a normal command, a dash mode command available, and it is used for creating the partition and doing other activities you can see here. So it can create dash partitions, change an existing partition on the fixed disk, delete an existing partition, and fourth is display current partition informations. So I can put fdisk/status command to get the current detail about the hard disk drive. So in case of Windows, what I can do is I can use the Diskpart command. So go to a command prompt, run as an administrator, use the Diskpart command. So once you run the command, you'll be able to see list of hard disk partitions available. So by using which we can further proceed. Step 4 is the select the drive to format. If at all I wanted to format some of the drives, select the disk by mentioning the specific number. So we should be very careful, because if you do that, there is a high possibility you'll be losing the data if there is any mistake, right? If at all you wanted to do disk 2 but by mistake you just pressed disk 0 or 1, so it may create a problem, right? Erase the data. So you should be very careful on specifying choosing the drive. Then clean the disk. Just type the command clean, it will clean the disk and create a partition primary. So it will create the partitions in the primary space. So after partition is created, now what we are going to do, we are going to format it. So this is a two-step process. You have to remember, create a partition, format it. Now what I am doing is, while formatting itself, I am just specifying file system as NTFS. So FS is a file system. So I'm mentioning NTFS. I can choose FAT also. We'll see the difference between FAT and NTFS in coming slides. So this is command for formatting. So in interviews or in exams, they may ask what is the command used in Windows for formatting. So it's a simple command, format. But again, what I'm saying is file system I'm choosing as NTFS. Otherwise, by default, it will format it as a FAT32. Assign a drive letter. This is required, so you can just do it. So the next one is, apart from the command prompt, how you can do it in the disk management. So disk management is a tool for managing your hard disk drives in Windows 10 as a graphical tool. So you can just go to run and type diskmanagement.msc to open the console. And there are other methods also available, right? You can right click on the PC and choose the management, then you choose the disk management, or you just type disk management in the search window. It will give you the option. You can choose the disk management. Either way, you can go for reaching the disk management utility. Once you open the console, so now we are going to proceed like creating a partition. So we are just mentioning it shrink volume because there is no free space available. The entire space is occupied, right? The C drive is occupied with complete storage. So there is option like shrink volume. Once I right click, I have the option as a shrink volume, and I'm going to mention what is the size required, maybe 100 GB or 500 GB, 50 GB, whatever it is. I can mention it, and I can just go ahead. So once I click it, it will shrink the original C drive and get that 50 GB or 100 GB space, and that becomes a simple volume. I can right click on the simple volume, and I can mention what is the size required. So then I can just finish on with the formatting of the partition. So with that, we'll be able to complete the partitioning. So this one here, we can just choose the NTFS as a default option and complete the format. So it will take hardly 3 minutes to 4 minutes to complete the partition, formatting. So this way you can easily do the partitioning and the formatting more than command prompt. It will be easy for the users execution. So now apart from the for partitioning and formatting, there is another concept called GPT, guided partition table. So it is one of the architecture for partitioning the disk drive to store the data. This is basically derived for accommodating the large partition size. So now we have some limitations, right? So with that, we will not be able to go beyond 2 terabytes with the FAT or NTFS, right? So 2 terabyte, more than that, we can 2 terabytes for NTFS. We cannot have more than that. So in case of GPT, guided partition table, we can have it up to 18 exabytes. So that is the advantage of having GPT. And GPT also supports the protection for MBR, so that anything happens to MBR, it will get safeguarded, so there will not be any problem in restoring the data. So normal MBR it works only 2 terabyte in size, not more than that. So this MBR supports only 4 primary partitions. We cannot have more partitions like that. I just mentioned in the previous slides. I can have 3 primary partitions and 1 extended partition, or I can have 4 primary partitions alone. I will not go for any extended partitions. I have 1000 GB of hard disk. I'll just put 250 GB in 4 primary partitions. I'll just close this chapter. So I can choose on my own. So in case of MBR, right, it will be stored in the master boot record is stored in the cylinder 0 and track 1. Cylinder 0 sector 1. and it is only one copy available. So if anything goes wrong, the entire hard disk data will be unavailable. So that is the drawbacks of the existing MBR. Now the advantage of GPT is, so it is a guided partition table, and it maintains GUID for each of the partitions, and it is unique identifier. So each system will have the unique number, and it can have up to 128 partitions, right? So not like your FAT or NTFS with 24 partitions, A and B given for floppy drives, C to Z for hard drives. So 24 partitions. Here I can have 128 partitions using the GPT. So if normal MBR stored in one place, so if it is overwritten or deleted, the entire hard disk data will be gone. Whereas in GPT it stores multiple copies across the disk, so that even if one deleted, we can restore it from other copy. So GPT also stores CRC and ECC data, so that if any error occurs, it can rectify the error messages. So GPT drives tend to include a protective MBR. So once your MBR is protected, so you are free from any other threats. So that's a very good advantage of having GPT. There are other partition tools. Suppose you are not comfortable with the command prompt or the Windows disk management. For making you easy, there are a lot of other partition tools available that works better than the disk management. I have used Ease US Partition Manager and Partition Logic. So those tools are very effective and very easy also. I can um, create partitions without affecting any of the data. So that is very good compared to other tools. So next is the file system. So what is a file system? It is what used for storing the data. How what is the type of data we are going to have, and it is going to help you with the fat tables for storing the data. And the operating system can store the data in any one of the file system. So this depends on the operating system also. Here we are discussing mostly with the Windows, so we are using the terms which is referred for Windows operating system, right? For Linux or any other operating system, it will be a different file system. So now it is Windows, so we deal with FAT file system and NTFS file system. So we had initially FAT file system, FAT16 file allocation table, right? So FAT16, so it is basically used with DOS or earlier versions of the operating system. This has some limitations. It cannot store more amount of data. File size cannot be extended beyond certain limit. Then we got it to FAT32, where we can have single file up to 2 GB, 2 GB of size, and partition can go larger size, right? So the advantage of FAT file system is with MS-DOS FAT, it can have only name of 8 characters, whereas the FAT32 can have 255 characters. It can allow the special characters in the names, and names should start with alphanumeric standards. It can also contain periods and spaces. Security part, that is a normal one naming convention. Security part, FAT doesn't provide any local security or folder level security. So user, if any user logs into the local system, he has the access to complete data. He can do anything with your data. While coming from network, at least I can have folder level permission given, and I can restrict it till folder level. I cannot restrict till file level. So some kind of restriction we can do it. So and FAT gives quick access to the files also. FAT32, it is advanced version of FAT file system. So it can have drives from 512 MB to 2 terabyte in size. So it is compatible with Windows latest operating systems also. FAT32, it is compatible. Like even still, I can create FAT32 file system and store data. Very much I can use the data between FAT and NTFS. That should not create a problem. So FAT32 has a limitation of larger size like 2 terabytes. It can support, and it also has very good access speed. So next is NTFS file system. After FAT16 and FAT32, NTFS is mainly recommended by Windows network operating systems like Windows NT. From Windows NT it is there, and the current operating system Windows 10 also recommends to go for NTFS file system. That is new technology file system. They have not changed the name till now, so they are using the same naming conventions for NTFS. So from Windows NT itself, we are having this kind of file system, and here same kind of naming conventions, but security side we have like it gives a file level security also. Apart from the folder level security, it gives file level security, and we can restrict the data even for the local users. So if I log in with multiple users, right, if I say only this user can access my data, yes, they can only access the data, others cannot access your local data. By that way, even for local systems, you are able to provide the restrictions. And it has a SID, just to have more security. They are providing SID for each users. Partition size, it can go up to 16 exabytes, right? The practically we are limiting with the 2 terabytes, but the actual calculation it can go up to 16 exabytes. Likewise, the file size, one file size can go up to 4 GB to 64 GB. Practically not possible, but still. Um, we can have file size of this much as a one file. You take a movie files and all, right, one file comes with the 2 GB or 3 GB. So likewise, if it is a lengthy one, it can go up to more size, 6 GB, 8 GB also. But getting a file for 64 GB is not practically possible, but still it supports that much file size. File compression, it is giving good compression, higher compression, 50%. It has high reliability, and it is also providing bad cluster mapping, so that the data will not be stored in the bad cluster. The difference between FAT and NTFS is provided here. So FAT doesn't provide any security, whereas NTFS provides a security, file level security at least, the granular level, and there are 7 permissions provided for a file. So users are restricted, like even only for reading or only for changing, that kind of restrictions we can give. So here, in case of FAT, only folder level security permission can be provided, and local permissions cannot be given. It supports 8 character file system, FAT16, whereas NTFS supports 255 character file system. So the FAT, the older one, FAT16 or FAT, right, it is supporting the 500 MB hard disk size for partitioning. It is more than 500 MB, and FAT32 file size can go up to 4 GB. This NTFS can go up to 16 exabytes. And the FAT doesn't provide support for any compression, whereas here 50% reductions we can get. FAT is not reliable because it is not providing back cluster mapping. So it will try storing the data in the back cluster, then later we are getting the failure message while retrieving the data. But in NTFS, it is being protected. So that's a difference between your FAT and NTFS. Next is low-level formatting. So we have seen high level formatting. So this is the concept of low level formatting. It means that we are going to do the deep dive formatting, and erasing the data completely from the hard drive, and there is no possibility of restoring the data once you do the low level formatting. There are tools available. With the help of the tools, we'll be doing the low level formatting, solid state drive toolbox or HTD low level format toolbox. So normal format, what we do after creating partition is a high level format. So using the format command in the operating system, DOS level, or right click on the disk management tool doing the format, it is a high level format, right? It is just erasing the FAT tables available in the partition, and recreating the FAT tables so that it stores the data. So by mistakenly, if you deleted the data by formatting, there is an option with the help of third-party tools. I can run the tool and recover the data which is stored before formatting the system. So that way it is very useful. But security perspective, if at all I am selling the system to the external third-party vendor, so I will do only low-level formatting. So nobody can restore the data from the particular hard disk. So high level format is faster compared to the low level format because low level format does the formatting every track, every sector, low level deep dive format. Whereas in high level format, it flushes the fat table and creates the new flat table. That's it. Compared to high level format, low level format makes high impact because data is lost and you cannot recover it anytime. So once gone is gone. So you cannot restore the data from the low level formatted hard disk. So there's example given like how to go for formatting the hard drives, specific drives. Either I can go to disk management and I can do it by right clicking, or in the my computer I can go and do a right click on the particular drive and go for formatting, or I can choose Diskpart command for doing the formatting. So apart from the ID hard disk, we got the another version of hard disk called SATA. This is the advanced version of hard disk. The interface is made different because of which the throughput have improved, and we are able to get a faster transaction of data using the SATA hard disk. So there is no technology change inside the hard disk. It is following the same standards, whereas the interface is changed, especially the connecting cable, right? The number of, we had a 40 pin cable earlier, a flat cable. Now we'll be having a 4 pin cable, red color cable, which is a SATA cable used for connecting the hard drive. Even the motherboards will be having minimum 4 to 6 SATA ports available. Your hard disk can be connected. Here, in case of SATA, we cannot connect two hard disks together in a single cable. One cable can have only one hard disk, so that is a big difference we can see from IDE and SATA. So, you'll have 4 ports, no? So you can connect 4 hard disks minimum. You can connect it. CD drive also can connect it via SATA ports if at all you have a CD drive with SATA ports. So that's the difference provided. So SATA cable and SATA power connectors. There is a eSATA connection available. Like your external hard drive, even you wanted to connect instead of USB external hard drive connection, you wanted to connect via SATA ports. There is a eSATA available that is called external SATA. So you can have faster transaction with the help of eSATA connection. It can go up to 2 meters of length, so it will be easy for you. USB is restricted with length, right? So within a meter, 1 meter, so it can go up to 2 meters. So that is an advantage. Difference between SATA and PATA. The main difference lies is SATA is faster compared to the PATA, that is a parallel ATA. Whatever we had, its ID is a parallel ATA. SATA is giving you more speed and as well as more performance. So the data transactions and operating system functionality, everything is coming with good quality and higher throughput. That is the best advantage of having SATA inside the system. So more than SATA, the next available technology is SSD, solid state drive. So till the time SATA also having the same kind of magnetic disk, right? So we have right from the beginning we are having the technology of storing the data in the magnetic disk and drive, where we had tracks and sectors and all this read and write used to happen. The new trend of hard drive is SSD. Now, most of the laptop and desktops are coming with SSD, and the rate is also less compared to the normal IDE pattern hard disk. So, people preferring to go for SSD, and even if you take the storage devices like NAS storage, SAS storage, they are started using the SSD hard drive where the cost of storage is being very less compared to the existing storage devices. So what is SSD and how it is constructed? So SSD, it is a non-volatile storage like your normal hard disk. It is made possible with the help of the transistors and NAND gates available. Electronic components, right? We have electronic components. It stores charges for a long time, so it will not get discharged. So it is a non-volatile storage drive, like your memory flash cards, right? So it is also a larger size of your flash card, so it stores data for longer time. There is no tracks and sectors here. All the components are electronic circuits, so there is no wear and tear, no head crash, there are a lot of advantage when you use SSD. So now the people are started going with SSD technology. Just simple example is given here. All components are IC based, and still the research is going on to compress more data into the SSD hard disk and get more output from the SSD. So normally, whenever we go for kind of backup storage, so we prefer to take SSD because there is no much read and write is required on daily basis. So it will be permanently kept. Whenever I wanted, I can connect the SSD disk and read the data. So the form factor, as such, your previous hard drives, there is no restricted form factors for SSD. So this is helping them to have very good capacity of hard drives manufactured. There are different sizes available, and with this help of SSD, with less occupying space, physical space, we are able to store more amount of data. It is available in different forms, as you see in the pictures, as a memory card, as an interface card, or as a stripe, right, magnetic stripe, small grid. So you can have SSD with higher capacity. So it becomes more flexible, more mobility, right, with the help of SSD. So that is giving the advantage of having a good mobility for data. So difference between SSD and hard disk drive, it is provided. So apart from the magnetic storage devices which is connected with the system, we have offline storage devices. So some of them are zip diskette. We had a zip diskette when we had a floppy drive concept. We had a floppy drive with 1.44 MB capacity. In that time we had a zip diskette of 100 MB. It looks funny now because we have flash drives with the 128 GB capacity. So but at that time, right, we when people had 1.44 MB capacity, so a person having 100 times higher capacity, right? Zip diskette is 100 times more than the existing capacity, so that was working fine. And the next is flash drive. So with the help of USB port, we are going to read it. So we have different varieties of flash drives with higher capacities also. Based on the budget and based on the requirement, we can go and buy it. And we have memory cards which is used with mobiles or even the external cameras or any other things we can use. So there is also coming with GBs, 128 GB capacity also, we are able to get it. So next is a RAID. This concept is mostly used with server technology, not with the desktop model, but still just for knowledge purpose, since we are having the um, uh, hard disk related. So just to have some input, you can go through this RAID concept. So RAID is redundant array of inexpensive disk. So we have a failure of hard disk. So if one hard disk fails, immediately the entire data is lost. So that is the case for desktops. But the same thing we cannot apply for servers, right? So what we do, we have rack of hard disk, we connect it together. We use a SCSI interface which has a capability of connecting multiple hard disks. So based on the type of RAID what I'm going to use, I can safeguard my data. So one is RAID 0, that is called striping. So in case of RAID 0, multiple hard disks are tied together or configured together, and if at all I give the data for writing, right, so it is parallelly written to uh, by the hard disk. So data can be written into the hard disk faster. So access time or seek time, if you see, it will be more compared to the normal hard disk time. So that is called RAID 0 striping. Here we get the benefit of reading and writing of data at a faster rate. No other security or no other benefit. Whereas in RAID 1, it is called mirroring. So what happens here is we have two hard disks. The second hard disk will be mirrored with the first hard disk. So anything happens with first hard drive, we can remove it and you can still work with a second hard disk. Whatever the operating system you had, configurations you had, it will be still running with. So you'll not have any problem in the data. So later you can remove the faulty hard drive and insert the new hard drive, then sync it, right? Another, again, you have to go for syncing the old data with the new data. So again, the first hard drive will come to the 100%, same thing with the second hard drive. So mirroring will be getting completed. So here you are getting the benefit of keeping the system alive always. There is no impact of failure of one hard disk. So RAID 10, striping and mirroring, that's a combination of RAID 1 and 0, so RAID 10. RAID 5 is striping with parity. So when you do RAID 0, it is only striping. There is no parity check made, right? So whether it is written properly or not, or whether I can retrieve the data from the disk properly or not. Whereas if I go with RAID 5, a separate hard disk will be used for storing the parity bit, and I can ensure that my data is retrieved properly and there is no damage for my data. So you'll have a separate space given for parity bit allocation. Though I'm going to consume more hard disk space, but the data stored in my hard disk is secured, and anytime I can restore my data whenever it is required. So that is a RAID 5. So normally we go with mirroring and RAID 1 and RAID 5 in the practical implementation, so that for my hard disk partition where my operating system resides, maybe first hard disk is having my operating system, rest of the hard disk are data storage. What I will do mirroring for my operating system hard drive, and I will go for striping with parity for rest of the data hard drives. So that way I can protect my operating system and I can retrieve the data from the storage devices. So with this we are coming to a conclusion of part 2, and part 3 we have, so in that we'll discuss more about the diagnosis, troubleshooting, and about the hard disk drive. Thank you.